So now we're going to look at some of the basics regarding the design principles, the main design principles of Java, and what essentially are objects, and looking at the essential principle of inheritance within Java. So think of a class as a blueprint for an object. So you've got a computer program you want to create, and you want it to be able to create lots of different objects within memory, within runtime, to do some kind of task for you. You need to tell the runtime environment how to create those objects, and the way you do that is you create these things called classes, which are descriptions of the objects. So objects are defined in terms of classes. Knowing the type of a class of an object tells you a lot about what it does. So if you've got a class and it's called pen, for example, then you know that the class should have some kind of a method to write, or it should have a method to add ink if you wanted to represent a real world type of pen, and any other methods that are necessary for a pen to operate correctly. So the name of a class tells you a lot about what an object is supposed to do. Another example, we expect bicycles to have 2 wheels, handlebars and pedals. So an object will have 2 main components to it, or a class that describes an object will have 2 main sections to it. There'll be the data section, which tells you all the components that it's composed of, all the primitive types, all the objects that compose and create that object once it's created. And you also have another section which is all the operations that you can perform on the object. Okay, so all the different methods. So we've got data and we've got operations on the data, basically. So those 2 elements are the main elements of your class to create objects. So object-oriented systems use something called a class hierarchy, defining subclasses in terms of superclasses. So we have basically what we have is a relationship between the types of the classes. Ideally, if you've got 2 similar classes and they belong to the same group, so for example, if you've got animals and you've got different types of animals like monkeys, cats, or whatever, then you think that, okay, there's some kind of similarity between all these different types of animals. Maybe we need to put them within a hierarchy so that you can reuse some of the codes, reuse some of the data types, so that you're not recreating that same code over and over and over again. Okay, so that's the main use of having a type hierarchy. It's basically saving effort and time so that you can reuse all that code, okay, and all those data types. So we have this thing called a class hierarchy, defining subclasses in terms of superclasses. And normally what you have is the more general type at the top of the superclass of the hierarchy, and the subtypes here are more specialized. So here you have your animals, and here you have your cats and your dogs, for example. So you have this kind of relationship where cats and dogs are types of animals. Animals will have some general behavior, and cats and dogs more specialized behavior, and so on and so forth. You have breeds of cats and breeds of dogs if you want more specialized classes below that. So another example that we have here is mountain bikes, racing bikes, and tandems are all a type of bicycle. So you'd have a hierarchy. So you've got bicycle at the top and those subtypes at the bottom, those specialized types at the bottom. The bicycle class is a superclass of the mountain bikes, racing bikes, and tandems. So you can say that the bicycle is a superclass of those lower classes, or those lower classes are subclasses of the upper class. And here are the features of a hierarchy. So each subclass inherits the state and methods of its superclass. And when we say state, we mean the data components. Okay, so the data components that form any object are basically what we call its state. Okay, so any objects that form a bicycle, any primitive types that you need, like wheels, for example, pedals, any other values like the serial number of a bicycle, all these bits that form the bicycle together, we call them the state of the class, or the state of the object. And each subclass inherits the state and methods of its superclass. So if you place classes in a hierarchy like this, then automatically the lower classes inherit the characteristics of the upper classes. So mountain bikes, racing bikes, and tandems share some behavior, for example, braking. So they all you need to be able to brake the bike. So you need to put this functionality somewhere You can put it in each one of those, but that doesn't make sense because you're repeating that operation over and over and over and over. It makes sense. It makes more sense to place the break-in behavior at the high level class, and they all can inherit it and they all can make use of it. And that way, if you create other types of bicycles later on, you don't have to keep recreating that behavior which has already been created for you. So braking, changing pedaling speed. So there's a number of operations, a number of things that are common to all these subtypes. So another thing that you can do is subclasses can add state and methods not available in their superclasses, and that's how you specialize them. So they automatically inherit everything from the superclass, but you can add whatever you want on top of that to make them more special. So for example, the tandems have 2 seats and an extra set of handlebars, for example. Other things that you can have is subclasses can override inherited methods. So if you've got a method in the superclass called brake, you might have to have it in a tandem bike. Usually has 2 seats on it and 2 people sitting on it. So maybe you need to brake a little harder. So maybe the braking algorithm might be slightly different to make sure you stop quickly enough. So maybe you want to override the brake method and add a little bit more to it to specialize it for the tandem bike, for example. I don't know. Or for example, a race. Some bikes will have brakes in the pedals and the handlebars. Others might just have them in the handlebars. So you might want to specialize various methods depending on the type of bike. So another example, a mountain bike might override the change gear method of its superclass to use extra gears. Okay. So the inheritance tree can be as deep as necessary without limit, so you can have as many layers as you want. Methods and state are inherited down through the levels. So right at the top, you've got something called the object class. So this is something you don't need to specify in, and it's already specified for you. Any class you create in Java automatically inherits from something right at the top called the object class. So that's a class with, so they created this class called object, and any class that you create automatically inherits all the state and all the methods from the object class. Yeah, a variable of type object can hold a reference to any object, an instance of any class, or an array. So this is another useful thing of having a hierarchy relationship. So for example, this is something that you can do. So if you've got a bicycle tandem relationship, so you've got a number of different types of bicycles, then you can do something like this. So you can say bike. So I'm not going to write the whole words because I don't have a proper pen. So let's say this is bicycle is equal to new. So you can say bicycle here, but you can say any of the subtypes. Okay? So you can say B is equal to new tandem. And then you can, I don't know, initialize it with some values. Okay? So a variable of type bicycle can hold a reference to its type or any of its subtypes. So imagine you've got some kind of a class and you've got a method which does something to all types of bicycles. You don't want to create a different method for each of the subtypes. You just want one method which does something to each bicycle. For example, store bicycle. Okay, so a storage method should be able to take any type of bicycle, and the way that you do that is that so let's say you've got a method store, and here you want it to be able to take any type of bicycle. Okay, and because you've got this hierarchy relationship, you can place any object within this bicycle object here. So it can be a tandem, it can be a racing bike, it can be a mountain bike. Okay, and the only reason that you can do that is the only way you can do that is through this here. You say bicycle B is equal to new T, or new tandem, new mountain bike, new racing bike. So that's where it becomes useful. That ability becomes useful. So a variable of the super type can hold an object of any of its subtypes. And because object is the top level class and the top level object of any program, so a variable of type object can hold a reference to any object of any of your programs. So object is useful in that it provides behavior common to all objects running in the Java virtual machine. for example, all classes inherit these useful methods: equals, hash code, and toString. Okay, so these are very useful methods, and we'll be talking about them a bit more later. So this is an example of a hierarchy to represent people that go to a university. So at the top level, you've got a person to hold some common behavior for a person. So you've got some common behavior for a university person, whether they're students or staff or anybody else. And then you want to specialize them, so you've got students, lecturers. So you notice here that lecturer and student extend university person extends person, and person automatically extends object. So you don't need to, so you don't do anything here. So automatically all this hierarchy here automatically extends object. So superclass code can be reused by many subclasses, each of which can provide specialized behavior based on common superclass elements. So this is something I mentioned earlier. You can define things called abstract classes or abstract superclasses, and they're used mainly to implement common behavior. And what you do in the subclass is complete the details. So the benefit of having an abstract class is that if you want to create a class that cannot be instantiated. So in this previous example here, it doesn't really make sense to allow anybody using your computer program to create an object of type university person, because it's just too vague. You want them to create something more concrete. So what is a university person? It's a lecturer, it's a student, etc. So those are the types of objects you want to be able to create it. So university person will normally be an abstract class. It won't be a full class. So an abstract class is just a placeholder where you can have common behavior. So you create a number of common methods for lecturer and student, and you place them in university person so that you don't have to repeat that code in lecturer and student and any other subtype. It's just a place to put your common code in. So classes and inheritance hierarchies convey important type information, but do not use inheritance just to acquire behavior. Okay, so respect there is a relationship. So make sure that something is something else when you use inheritance. Okay, so so for example, just because a good example, I'm trying to think of a good example. So but going back to our bicycles example, so bicycles might have, the bicycle class might have a brake method, okay, which is useful for, I imagine, for lots of different vehicles. But you don't really want to create a subclass of bicycle and call it a car or BMW, because a car is clearly not a bicycle. Even though you'll get that behavior, that braking behavior from the bicycle class, it doesn't mean that you sort of abuse that relationship, that inheritance relationship. So when you create an inheritance relationship, you want to make sure that something is something else. When a class extends another class, it has to be a type of that class. It has to be clearly a type of that class. So a tandem bicycle is clearly a bicycle. A mountain bike is clearly a bicycle. A car is not a bicycle. So put that in a completely different hierarchy. Even though you might get some useful behavior from the bicycle class, like brake, it's abused in other ways, in other areas. So all the other behavior doesn't make sense for it. So don't use inheritance just to acquire behavior. Respect there is a relationship. It does not mean behave like. It has to be the same type or very close type. I'm just going to go through some of the details just in case you're not familiar with Java. So this is how you declare a class in Java. So the keyword here is class, and you're creating a class. It's a blueprint for the objects that you want the runtime environment to create for you. So once you create this declaration, what you're saying is that you want the runtime environment to be able to create objects of this type. In this case, it's a type of person. And what you're saying, so we'll talk a bit more about these here a bit more. So what you're saying here is this class is public, which means that any other class should be able to access this class and access its member variables and manipulate them and be able to manipulate the person itself. Okay, so you're not placing any restrictions, any access control restrictions on this person. You're not saying that person can only be accessed by a certain class or a certain number of methods under your control. You're saying that anybody can access person, anybody can create a person, access its methods, and manipulate the objects. Okay, so there's no security issues. So for example, you would not, if you were a bank and you were creating a person object for your customers, this is not how you would do it. Okay, this would be a dangerous way to do it. You would not say that this person is public here. Otherwise, anybody would be able to go onto people's bank accounts and change all the data. Okay, anybody who has access to the system would be able to do that. So normally a bank, if they were implementing this in Java and creating some kind of a record for their customers, this keyword here would be private, so that only classes with the right access control authorization would be able to access it. Okay, but here we're saying that it's public for our example. But even if you declare a class public, you should always declare its member variables to be private. Okay, so this is an important convention in Java and in most object-oriented programming languages, as far as I'm aware. You declare the components that compose the object as private, so you don't want other classes to be able to come in and manipulate this data directly. Okay, you want to have some kind of control over that data, and the way you control access to that data is through the methods themselves. So you declare the methods to be public. Okay, so I can go in this case there are no methods to manipulate this data. All you can do is get the data. To manipulate the data, for example, you'd have another method here that says set name. For example, you'd have a method to say set age, but we don't have that here. So we've removed those methods. So we've restricted control to the name and the age of the person to something called the constructor. So this is the constructor here. So when somebody says person, for example, P is equal to new person, etc., etc. So what are you doing? So you say new person. When you say new person, what gets called is this constructor here, and you notice that the person constructor has exactly the same name as the class itself. Okay. So that's the definition of a constructor. It's the same name exactly as the class itself. So that's a constructor, and it's a place where you initialize all the values of your objects. So whenever somebody wants to create an object of type person, they say person P is equal to new person, and they specify their name and they specify their age immediately. So they say their name is John and then 30, for example, and therefore that object's been created. It's an object of a person. Their name is John. Their age is 30. And what you can do with that object later on is that you can get the name whenever you want to. You can say p.getName, and it'll give you the name of John. Say p.getAge will give you John's age. Okay, and in this case you can't change the name and the age. Okay, so once you create the object, it can't be changed simply because there are no methods available here to make that change. There are no set methods. Okay, sorry to go over the basics a bit too much, but just making sure that everybody's on the same level here if you haven't used Java before. So now we look at university person. So this is where we look at that inheritance relationship between the university person and the person. So if we go back to our diagram, so you notice here, there's our person and there's our university person. And we want this inheritance relationship. So we want university person to extend person. And the way you do that is you use the extends keyword. Okay? So you say university extends person, and by doing that you automatically acquire all the data and the behavior. Okay, so we automatically inherit these data types here. We inherit the name of the person, we inherit the age. So you don't need to declare them again. They've already been declared within the person class, so you do not need to declare those again. And you do not need to declare, you do not need to create those methods either. They've already been created because there is an inheritance relationship. It means you can make use of those. So all you need to do is add whatever specialized behavior you want to add to person. So you say extends person, and here we're adding the specialized behavior here, which is the name of the institution. So I've created another variable. It's a string variable, and it's the institution. So what university are we talking about here? So we declare, again, you need to declare a constructor. So it's the same name as the class itself, public university person. You still need to, if you want somebody to create an object of type university person, then you need to give them the ability to do so, which means that you need to pass those values to the constructor. So if I create a object of type university person, so university person, U is equal to new university person, you need to give them the ability to give those values. So the values are the name, all the names specified previously, so the name, the age, and now the institution. But you don't need to initialize those first two names here. So the name and the age, remember, have already been initialized within the person constructor. So all you do is you call that constructor in. Okay, you make use of the person's constructor. It's already been created for you. There's already a constructor that initializes the values for you, so make use of it. Okay? So what you do is you use a keyword called super. You say super, name, and age. Okay? And what that does, it automatically jumps up the hierarchy. It jumps up to the person class here, and starts this constructor here. And it automatically initializes those values here. Okay? So it automatically assigns whatever values you give to these variables here. Okay? Too much red, I know. Okay. So all you have to do is say super, name, and age. So that automatically initializes those values for you. But the new data you need to initialize here for the first time. So you say institution is equal to institution. So what you're doing is institutions being passed into the constructor here. So you need to pass that value into the global value here. Okay. And so as I said, you acquire all the other behavior. You acquire the get name method. You acquire the get age method. But you need to add whatever's new here. So you're adding the get institution method, which returns the value of the institution. Okay, which is the name of the institution. So for the student class, so now the student extends university person, and so the student, therefore, by using this extends keyword, they're inheriting from person the name and the age, and they're inheriting from university person the institution name. Yeah. And now we add anything new we want. So a student has a stage. What stage are they in, for example? So we're adding this new stage variable here. And obviously within the student, if you initialize a student, if you say something like student S is equal to new student, you need to be able to initialize all of their values. So you want to be able to initialize their name, their age, their institution, and their stage. So the other three variables, which are name, age, and institution, you just call the constructor that's above, the constructor of the university person, using the super keyword again, and you just initialize the value of the stage here and here. So that's the specialized behavior of this class, and you just need to add this method here, the get stage method. You don't need to add the other ones because they've already been added for you. This is how you would use student. Okay, so this is how you would create an object of type student. So here we've got something called our main method. So you place this somewhere in some class where you want to run your program from, and the compiler or the runtime or the Java runtime environment always looks for this main method. It finds it and it runs any instructions they have in there for it. So here what we're doing within our main method, we're creating a student Bill is equal to new student, and we're giving it its main values. So the name is Bill Gates. Apparently he's 45. He should be about 65. So 45. So he's from Harvard University and he's in stage 3. Maybe that's his age when he went to university. Yeah. Looks a bit strange though. Yeah. So this is how you initialize. So that's all you need to do. You say student Bill is equal to new student. You pass it all the values you want to pass it, and in order to know what values you should pass to it, all you have to do is look at the documentation. Usually all Java classes. So if you look at the Java API for any class, they'll tell you what this constructor is expecting from you. So what kind of data is expected to be passed into the constructor. Okay, so it'll tell you, for example, you should pass it a name, an age, an institution name, a stage, if you document this one. And so you pass those values, and that's it. You've created the object, and it has the values initialized, and then you can do whatever the object allows you to do. So in this case, these are the only operations which are available to us. So get name, get age, get institution, get stage. So this is how we created the classes, that you can only get those values. So this is what you can do. So this is the main command to print something into the Java console, system.out.println. So you need to type that in anytime you want to print something into the console. If you want to test your programs, debug them, and that's how you would do it. And you say Bill, so the object dot whatever method you want to make use of. Okay. So notice that even though Bill is a student, so the object Bill is a student, you have access not only to his stage method, but all the methods that's in the superclasses as well, like get institution, get age, and get name. Okay, so all the way up through the hierarchy, you can access all the other methods. Yeah. So if we go back to the diagram, you'll notice that student extends university person, but also lecturer extends university person. So we created a lecturer class. So a lecturer is also a university person, so we can use the extends keyword, and we extend or inherit from the university person. So the lecturer therefore acquires all the behavior from the university person, and you just add whatever you want to add to this class. In this case, we want to add a school name. So the student had a stage, the lecturer doesn't have a stage. The lecturer has a school. And then we initialize all these values. This is the lecturer's name, their age, the institution they belong to, and the school they belong to. We initialize the extended behavior using the super keyword like before, and we just need to initialize the school value here. And then you add the get school method, and all the other methods you already get them through inheritance. Okay, and then to use lecturer, you might create a class called useLecturer. You have to create a main method. And let's say we want to create a lecturer name called Nick Cook. We have a lecturer here called Nick Cook. So you just call, so then you can call all the methods that you've inherited. So for example, you've inherited get name, get age, get institution, get school. And here we're trying to do nick.getStage, and says it gives us a compilation error. So if you try to do that, then it'll give you an error because getStage is not, you don't have inheritance sideways. Okay, so lecturer does not inherit from student, student does not inherit from lecturer. And the getStage method is being added at the student class, so it's here. It's not above lecturer. Okay, so that will give you an error if you try to do that. Yeah, so this is just going over which I just said. So the previous slide gives a compilation error. The method getStage is not found in the class lecturer. This is correct. Lecturers don't have stages. Lecturer and student are derived from the same superclass, but do not have identical methods. So note the use of super to call the constructor of a superclass, and super must be the first statement in a constructor. Okay, so you have to put that as the first statement. So the first thing you need to do, if your class is a subclass of another class, the first thing you need to do is initialize those values that are already been initialized in the superclasses, and the way you do that is by calling the super keyword, and that's how those get initialized for you. Okay. Overriding behaviors. So here's the task. Okay, so we wish to provide a print details method to the preceding classes that print the name, the age, and other information relevant to the type of person. So basically, you just want some method that prints the details out for you. The method should print details specific to the type of object on which it is invoked. So subclasses of person should override the print details method. They can reuse the behavior of the other superclass print details methods and print additional information relevant to the subclass. So this is how you would create the print details method for the person class. So in addition to the code that we saw previously, we add this code here. So void means nothing, basically. So you're returning nothing from this method. So your method is doing something, but it's not returning anything. Otherwise, it has to do something. Otherwise, there's no point in creating it. Its name is print details, and this is what it's doing. So we send system.out.println. This is a string here, which is static. It's never going to change. And then here you're adding the variable. So you use this plus sign, and then you add the variable that you want to get printed out. And then here, a person has a name and they have an age. So those are the two values that you want to get printed out. And then we move on to the university person, and this is how you add the print details method for that one. So remember, we want to make use of the behavior, we want to make use of the inheritance hierarchy in this example. So again, the keyword is super. Okay, so you first of all call the person print details by using the super keyword here. So super dot print details automatically calls the print details that we just saw in the previous slide, and then you add any specialized behavior after that. So you just print out the institution name. So automatically those two lines get printed, the name and the age of the person, and then the institution name will be added. Okay, so you don't have to repeat that code. And then the student, again, exactly the same thing. You create your print details method. You use a super keyword, and it automatically calls the print details of the class in the hierarchy that's above this class. So you get the age, the name, and the institution, and now you add the stage. Yeah. So this is called overriding. So overriding is very powerful. When there are several versions of a method in a hierarchy, the implementation in the referenced object or its closest superclass will be executed. Okay. So we look at the closest object within the implementation. So yeah, irrespective of the type of the reference. So here's an example of something that we can do. So person P, let's say we're creating an object of type person. So we say person P is equal to new person. So a person called Fred, and their age is 21. And we're creating an object of type student. Student S is equal to new student. The name is Eve. She's 18 from York, and she's in stage 1. That's York University, I think, the institution name. So if we say p.print details, so it says here complete the correct class names in the comments below. So if we say p.print details, so which print details does it call? Because it's an object of type person, so it looks in the person class, finds the print details method there and uses it. If we say s.print details, it goes to the student object, finds the print details method in there, and it prints that. So hopefully now we're printing all these useful values. So if we say p is equal to s, so the address of s will be in p, which means that p now points to an object of type student. So if we say p.print details now, it's called a student object basically, and the print details, it'll find the print details method within the student object and will print that. And yeah, but importantly, P is still of type person right now. Person P is equal to new students. That's what we're doing. Therefore, if you do this, then P has to have this print details method as well. So I mean, the person class has to have this print details method as well. If the person class does not have the print details method, then you won't be able to run it, even though it exists in the student class. It's because the compiler does not know what object you're trying to run. The compiler, before you actually run your program, will look at the reference type. It won't look at the object type. The compiler doesn't know what's happening at runtime. It only knows what's happening before you run the program. So if you try to say P is equal to print details and P is of type person, it can only look at the person class. It'll look in the person class. It'll say, does the person class have print details? If yes, then you won't have any errors. If no, then it'll give you a compilation error and you won't be able to run the program. But then when you do actually run the program, it doesn't run the print details method in the person class, it runs it in the student class, because the object itself it's created is of type student. So this is all mentioned here. So this is what we call dynamic binding. So the method that gets executed is decided dynamically during runtime. It's not decided at compilation time. So method overriding, so we call this dynamic binding. So this thing where the runtime environment looks at the object type and then dynamically decides which method to execute. It looks first at the object type, it sees if it's there, if it's not, it looks one up in the hierarchy, if it's not there, it looks one up. So this is something dynamic that's happening at runtime. Okay, so it's called dynamic binding. So each object has a table of methods. At runtime, Java searches the table for the correct version of an overridden method. The compiler does not know which method will be called. The compiler can only check that the type of the reference provides access to a given method. That's why the reference type has to have that object in there, that method in there. And so another And so sometimes you might not want a method to be overridden by a subclass, and the way you do that is you make use of a keyword called final. So if you don't want print details to be overridden, then you use the final keyword. You just say public final void. So then somebody comes along and tries to override print details and won't be able to do that. I'm not sure if it's the compiler. I think it's the compiler won't allow them to do that. So it prevents a subclass from overriding print details. It also gives efficiency, reducing the runtime search. Okay, so if you think of dynamic binding, if you place print details in person only, and you don't allow university person to override that, and you don't allow student to override that, then the runtime environment doesn't have much to do. It knows there's only one method, it jumps straight to that method and it executes it. It doesn't have to look through the different methods. It knows that there's only one method of that type. So it saves a bit of time, it improves the performance of your program. But sometimes that's not possible. Sometimes you want to be able to override to add more useful information to a method. So it just depends on what you want to do. So another thing that you can do is something called overloading. And overloading means that you have the same method type, the same method, the same name, but you want it to do different things depending on what data is being passed into it. So for example, if we look at the print details method, in our basic example here, so your print details method, you're not passing any variables into it. You just want it, I guess, to print into the console. So you're just printing some details into the console to help you debug your program, for example. But you might want it to print the information to different areas, to different outputs. So in that case, you might create another print details method and specifying what output stream you want it to go to. So that's something that you can do. So now we've got two versions of the print details method. One where you don't pass any information to it, and one, in this example, you're passing to its information. You're saying, if somebody passes this print stream into it, then please print it to this print stream, not just to the console. So we call this overloading. So basically what you're doing, you're overloading the method name. You've got several methods with exactly the same name, so we call that overloading. So to overload a method, declare a new method with the same name but different parameter list. That's an example. Then the method name is overloaded. The number and types of parameters determines which method is executed. Okay, so the runtime environment will look at the data being passed into the method, and that's how it knows which of the methods to execute, based on what makes sense. In contrast, overriding methods, which is what we talked about just now, overriding methods, which we talked about just earlier, we have identical parameter lists. Okay, so that's the same method being executed in different classes, but you have the same parameters. So you're passing to it the same parameters throughout the different classes. So the runtime instance of the object determines which version of the overridden method is executed, which is what we just talked about, which is called dynamic binding.